This lecture is the continuation of the previous problem that is discussed in video lecture FIN4. Here we have to calculate the heat lost up to a length of 158 mm. This is 158 mm. So in order to calculate the heat transfer rate up to a 158 mm, definitely you need the temperature at this cross section. So for that you use the temperature distribution equation, that is T minus T infinity divided by this one. Here T is the temperature at this cross section. T infinity remains the same. TB is the base temperature, that is 200 degrees Celsius. When you use this expression, you will be getting the temperature at this cross section, that is temperature at a distance of 158 mm equal to 53.04 degrees Celsius. So if you know the temperature at this cross section, you can calculate the heat transfer rate from the last 2 mm, because the total length is equal to 160 mm. This length is equal to 158 mm. So you need to calculate the heat transfer rate from the last 2 mm in order to calculate the heat transfer rate up to a length 158 mm. So heat transfer rate from the last 2 mm equal to K into AC into M into TB1, that is temperature at a distance 158 mm from the root of the fin minus T infinity. We already calculated the temperature at a distance 158 from the root of the fin. So that is 53.04 degrees Celsius. This is 53.04 degrees Celsius. So if you know this value, you can calculate heat transfer rate from the last 2 mm, which is equal to 1.457 watt. So heat lost up to a 158 mm, heat lost up to, that is, this is the fin, heat lost up to 158 mm, heat lost up to 158 mm equal to heat lost from the entire length of the fin minus heat lost from the last 2 mm. The heat lost from the last 2 mm we calculated as 1.457 watt. So you substitute in the equation, in this equation, that is heat loss from the fin up to a length 158 mm equal to total heat loss from the fin minus heat loss from the last 2 mm. This data we already calculated, that is 10.75 watt. This data, this is calculated as 1.475 watt. So heat lost up to 158 mm equal to 9.29 watt. So when you take the percentage of heat lost up to 158 mm, it is 9.29 divided by 10.75 into 100, that is 86.4%. That here what you have to note is the percentage of heat lost up to 158 mm is 86.4%, whereas up to the 80 mm the percentage of heat lost is around 63%. It indicates that majority of the heat loss is happening at a smaller length or nearer to the base of the fin. More heat transfer will occur nearer to the base, and when we go away from the base, the heat transfer rate is decreased.